Last time we started virtual work method for trusses, and we have some steps. First step, you need to solve the truss due to the given load. The second step, you need to remove all loads, all the given loads, and put only one unit load. Probably this unit load is horizontal, probably it's vertical, based on what is required. The third step, you need to solve the truss one more time due to the new unit load. Finally, you need to apply this equation using a table. And remember, in this method, a virtual work method, to calculate deflection at any point in truss, you need to keep in your mind that if your member in tension, your value must be positive. If your member in under compression, your value must be negative. And this information is very important, and I will cover it today. We covered one example last time. Let's start to solve this problem. We have a truss, hinge at A, roller at B. We have horizontal concentrated load 6 kilonewton at C, vertical concentrated load at D. We need to figure out, we need to solve this truss to calculate the horizontal deflection at D. Okay, I got it. First step, we need to solve truss due to given load. So go back to chapter 3. We have a truss with given load. So we have reaction here, YA. I think I have reaction XA will be in this direction. You are almost done with this course. So I can assume probably 90% my correct direction, the correct direction of a reaction. So I expect reaction at A in X will be to left. We have reaction at B, YB. We have 3 equilibrium equation. Summation F of X equals 0. I think this reaction will be 6. If you apply summation F of Y equals 0, if you apply summation moment at any point equals 0, I can figure out the remaining reaction. For example, reaction YB will be 6 times 3 divide 3 will be 6. If you apply summation F of Y equals 0, it's okay. YA will be 0. 0 is a number. I know you hate 0, but 0 is a number. It's okay. Your reaction will be 0. Then we need to solve this truss. Let's start with joint D. Actually, I don't have guides to help you which joint I will start. You can start with any joint, but keep in your mind, I cannot start with a joint with 3 members unknown. For example, joint A, I cannot start with joint A. Why? Because I have 1, 2, 3 members. All of them are unknowns. That means I cannot start because your joint can only solve for 2 unknowns. I cannot start with joint C because we have 1, 2, 3 members. Actually, I can start with joint B or joint, D or joint B. Both of them I can start with. Let's start with joint D. What do you have at joint D? Joint D, we have vertical load 6 kilonewton. I have horizontal member and vertical member, nothing else at joint D. I think I will assume this member tension and this member will be compression. This member FDA, this member FDC. If you apply summation f of x equals 0, this force will be 0. If you apply summation f of y equals 0, this force will be 6. This one is 0, it's okay. This one is 6, which is compression. Okay? So that means this member is 0. It's okay. This member under compression, it will be under compression on the other side. Your value will be -6. Remember, if your member under compression, please put your value in negative. If your member under tension, put your value positive. Yes, Carolina, I received your quiz. Thank you. Okay, what else? Actually, I can do joint B. So, joint B. What do you have at joint B? Actually, at joint B, here is joint B. I have vertical reaction, 6 kilonewton. I have horizontal member and vertical member. Nothing else at joint B. I will assume this force like this, FBC, and I will assume this force like this, FBA. Also, go ahead and apply two equilibrium equations, summation f of x equals 0. I think this horizontal force will be 0. So this member is 0. If you apply summation f of y equals 0 at this joint, I think this force will be 6, compression. That means this member will be under compression like this. It will be compression on the other side. Your value will be -6. Negative on this truss means compression. Positive means tension. We're still looking for one more member. I think you can apply joint equilibrium at C or A as you like. Let's start joint C. Okay. For joint C, what do you have at joint C? Everything at joint C, please. Here is joint C. We have horizontal force, 6 kilonewton. We have horizontal member here. We have vertical member. We have inclined member. Nothing else at this joint. I think this force is 0. I think this force was compression 6. So I'm going to assume this member as a tension, probably FCA. Go ahead and apply summation f of x or summation f of y. Any of them will work. Summation f of x equals 0. I can figure out FCA. FCA will be, I think it will be 6 divided sine 45. It will be 8.5 tension. I assumed it in a tension sign. It's positive. That means my assumption is correct. So this force will be tension and will be tension on the other side. Your value will be positive because it's tension 8.5. What you did until this moment, you solved your truss due to the given load. Solve the truss due to the given load, and these forces in these members can be called capital N. The first step is only one problem in chapter 3. Any question so far? Any question so far? If you have any question, let me know. Did you break up FCA? if yeah, you can break it to up, but actually, you remember for joint C we have only one unknown. So one equation will be enough. If you apply summation f of x will be enough. If you apply summation f of y equals 0 will be enough. Remember that this angle is 45 degrees. So if you apply, for example, summation f of x equals 0, you have FCA cosine 45, which is negative, plus 6 equals 0. Your final answer will be 8.5. Okay? So we need to be more flexible with these calculations. Just if you can do it with calculators, that will be fantastic. If you cannot, okay, go ahead and put all of details on your calculation. Second step. So, Brock, yes, I did break any inclined force to two components, f of x or f of y. Second step, go ahead and remove every load from your truss. That means your truss will be, looks like this, without any load. We have only hinge at A. We have roller at B. At B, we have C, and we have D. I removed all forces. We have 6 kilonewton and 6 kilonewton. I removed all forces. If you removed forces, your reaction will be removed also. So we have truss without anything. Please go ahead and put unit load. Where and how? Where I will put the unit load and how? Is it horizontal or vertical? So please go back to your problem. We are looking for horizontal deflection. Horizontal means your unit load will be like this, horizontal. 1 kilonewton, 1 pound, I don't care, it's 1 unit load. Where? At joint D. So please go ahead at point D, put horizontal unit load equal 1 kilonewton. And resolve this truss one more time. Resolve this truss one more time. But at this moment, we have truss, we have only 1 kilonewton at point or joint D. Go ahead and solve due to the effect of 1 unit load. Any question at this moment? Someone should ask me a question. He didn't ask me or she didn't ask me this question last time, but someone should ask me a question here. Any question? Any question? You should ask me a question. Alex, do you have a question? Is it tension or compression? What you mean, Brock? Is it tension or compression? I'm applying a force. Can you tell me, is this 6 kilonewton, is it tension? This one is tension or compression? No, we don't ask ourselves this question for external load. You ask this question for the force in the member. But for external load, no, this does not make any sense. So Alan, the problem asked to calculate deflection at D. So I put unit load at D. If the problem asked to calculate deflection at C, I will put it at C. And why I put unit load horizontal? Because the problem asking for horizontal deflection. Oliver's location based on we are looking for deflection at D. So I put unit load at D. Any question? Guys, you should ask me this question. Okay, this step, you removed everything. That's right. I removed everything. And I will put horizontal load, unit load at D, because you are looking for horizontal deflection at D. But the question is, how can I put this horizontal load? To right or to left? Someone will add it like this, 1 kilonewton. Why you put it like this? It's a horizontal. It's at point D. That's correct. But to right or to left? It's a good question. To right or to left? It's a good question. You asked me to remove everything and put 1 unit load at point D. And this unit load is horizontal. But you didn't tell me horizontal to left or horizontal to right. Okay. You can assume what you want. You can assume any direction, but horizontal. To right or to left, it's up to you. Assume any direction as you like, but to be horizontal. So you can assume horizontal to right or horizontal to left. But remember, keep in your mind, your load must be unit load and at joint D. To right or to left, it's up to you. You can assume what you want, but based on your assumption, you have to decide something at the end of the problem, and I will let you know. So at this moment, it's okay. You can assume what you want, to right or to left. To right or to left. You can assume what you want, but based on your assumption, I will tell you something at the end. Okay, go ahead and solve your truss one more time. So we still have two reaction. Reaction at A, it will be down, I think. And the reaction at A will be to left, and we have reaction at B will be up. If you apply summation f of x equals 0, this reaction will be 1. If you apply summation f of y equals 0 and summation moment at any point equals 0, I think this reaction will be 1, and this reaction will be 1. So all of your reactions are 1. But this one is up, this one is down, this one to left. Once you calculate your reactions, go ahead and try to make joint equilibrium. I will start with joint D. Joint D, we have horizontal load. I assumed at 1 kilonewton. Guys, you can assume any direction for 1 kilonewton, but this unit load must be at joint D and must be horizontal. I repeat it one more time. I'm talking about you can assume what you want. I mean to right or to left. But this unit load must be horizontal and at joint D. Why horizontal? Because we are looking for horizontal deflection. Why at point or joint D? Because we are looking for horizontal deflection at D. To be clear at this point. Okay, let's try joint D. Equilibrium at joint D. We have vertical member, we have horizontal member. This one will be compression, this one doesn't matter. If you apply summation f of x equals 0, this force FDC will be 1. compression. If you apply summation f of y equals 0, this force FDA will be 0. That means this force is compression. That makes sense. And will be compression on the other side. Compression means -1. This member is 0. What else? I can do joint equilibrium at joint B. Let's try joint B. What do you have at joint B? Joint B, we have vertical reaction 1. We have horizontal member FAB. We have vertical member FBC. I believe, because I have more experience, you should have also. This force will be down because we have one up, so this force will be down. This force, it doesn't matter because I expect it will be 0. If you apply summation f of x equals 0, this one will be 0. Nothing in horizontal direction except FAB, so FAB will be 0. Summation f of y equals 0. I think this one will be 1 in the same direction, which is compression. So the force in this member will be compression, negative. Compression means -1. The force in this member is 0. We are looking for member AC, so you can apply joint equilibrium at C. Let's try joint C. What do you have at joint C? I have, what do you have here? I have horizontal force 1. I have vertical force 1. I have inclined member. I expect it will be in this direction. This angle 45 degrees. If you apply summation f of x equals 0 or summation f of y equals 0, you can figure this force. It will be, I think, 1.4. 1. Tension. Tension and tension. So I solved my truss one more time, D2 unit load. These forces in your members called small n. Finally, do you remember what was the final step? Do you remember what was the final step? Which is most easy. Yes, most easy for fun. The last step is table. Go ahead and set up a table. First column in this table, members. Go ahead and put your member. Member AB, BC, CD, DA, AC. We have 5 members. Yes. 1, 2, 3, 4, 5. Yes. Second column, go ahead and put the length of each member. Member AB 3 meter, BC 3 meter, CD 3 meter, DA 3 meter, AC, I think, oh, wait. 4.24. Guys, the length of each member, 3 meter. Any vertical member, 3 meter, 3 meter, 3 meters. The inclined one, you can get it 4.24 meter. Then, what is the capital N in each member? Okay, go ahead and put capital N. This member is 0, -6, 0, -6. So 0, -6, 0, -6, and the inclined one is tension 8.5. So positive 8.5. What is the small n in each member? Okay, go ahead and put the values of small n in each member. 0, -1, -1, 0. 0, 0, negative 1, negative 1, 0, and the inclined one was tension 1.41. Finally, go ahead and multiply small n by capital N by L. This column times this column times this column, and put your value here. 3 times 0 times 0 is 0. 3 times negative 6 times negative 1 is 18, positive. 3 times 0 times negative 1, 0. 3 times negative 6 times 0 is 0. Then 4.24 times 8.5 times 1.41 equal 50.8. Go ahead and get your summation. So this 50 plus 18 equal 68.8. That means your horizontal deflection at D equal this number 68.8, which is positive, because this value is positive, this value is positive, your final summation will be positive. So your final answer is positive 68.8 divide AE. If AE is given, I can get the final answer for horizontal deflection at D. Any question? Any question so far? You should ask me a question also. You should ask me a follow-up question. So this method is very for fun. It takes a little bit more time, but it's very easy if you can solve the trusses. And to set up your table, just piece of cake. But your final answer is positive 68.8 EI. AE, I'm sorry. Aha, thank you, Ehab. Thank you. You are sitting in your car, but you're paying attention to me. Thank you so much. Yes. Anybody can tell me this deflection is horizontal deflection? Yes. To right or to left? Remember last week, we decided your deflection goes up or goes down based on the sign. Is it positive or negative? Okay. Here, your deflection was positive 68.8 divide AE. Yes, this horizontal deflection will be moved to right or to left? What do you think? To right. Why? Why, Brock? Why to right? Why to right, Oliver? Because it's positive? Yes. Go back to this step. You assumed your unit load to right. And your final answer of deflection was positive. That means you assume the correct direction. I don't care. I assume the correct direction or the wrong direction. My concern at this moment, yes, my deflection will be to right. If you assumed your unit load like this, that's right. And you set up your table. That's right. Your final summation here will be negative 68.8. That means your delta horizontal at D will be negative 68.8 divide AE. What does it mean of negative? Means you assume the wrong direction. So this point will move to the opposite direction, to right. You got it? So you can assume any direction. And I need to Pay attention. Any direction I means to right or to left. Then, after you get your value, you can decide which direction is the correct direction. Then you can decide this point will move to right or to left. And that makes sense. That makes sense for me because we have 6 kilonewton here. What do you think? This 6 kilonewton will move this truss as a total truss to right or to left? What do you think? I think this 6 kilonewton going to right. So the whole truss will move to right. And that makes sense. Yes, yes. Yes, Ihab. One more problem. We are looking for vertical deflection. Guys, we are looking for vertical deflection. Vertical deflection. So I expect to assume my unit load like this. Vertical load. Where at joint A. This is the next step. Okay, let's focus on the first step first. First step, we need to solve this truss due to the effect of 500 pounds. Okay, go ahead and start to solve it. I think we have a reaction here, XC. I think we have a reaction here, YD. I think we have a reaction here, will be XD. You can assume any reaction, any direction for your reaction. But if you can assume the correct direction, go ahead. So summation f of x equals 0, summation f of y equals 0, summation in the moment at any point equals 0. I think this reaction will be 500. I think this reaction will be 500 times 6 divided 3 will be 1000. This one will be 1000. And this one will be 1000. So apply equilibrium equation for reactions. Once you get your reaction, go ahead and figure out what is the internal forces in each member. I think this member and this member will be 0. We have joint with 2 members only, no external forces at this joint, the 2 members will be 0. I think this member will be 0. We have a joint with 3 members, 2 of them are collinear, no external forces at E, the third member will be 0. Go ahead and do joint equilibrium. Actually, I will start with joint C. Let's start with joint C. I will start with the most easy one. You can start with any. Joint C, we have horizontal reaction here, 1000. We have vertical member, we have horizontal member. I think the horizontal force will be in this direction, FCB. I think this one, it doesn't matter, FCD, because if you apply summation f of x equals 0, this one will be 1000. If you apply summation f of y equals 0, this force will be 0. I'm talking about joint C. What you have at joint C, we have horizontal reaction, 2 members only. So the vertical force will be 0. The horizontal force will be compression, like this, and the compression on the other side, negative 1000. Keep going. I can apply joint equilibrium at F. For example, joint F. Remember, I cannot solve any joint until you have only 2 members unknown. Do you have 2 members at F? Yes, I have 2 members because this one is 0. So I still have this one and this one unknowns. Okay, joint F. We have vertical force. 500. We have horizontal member. We have inclined member. What about the third one? It's 0. Forget it. So we have F, FB. We have F, FE. I'm going to assume this one like this, and this one like this. Go ahead and apply summation f of x equals 0, summation f of y equals 0. I think this one will be 707.1 compression, and this one will be 500 tension. So this force will be in tension, and this one will be in tension. Actually, you can assume this member is one member because you deleted this one because this one is 0. It's a positive 500, and this one is under compression. It's a negative 707.1. We're still looking for this member. I think this member will be under compression 707.1 negative. No, wait. I think this one, yeah, will be tension. This one will be tension. Sorry. This one will be tension 707.1. Yes. So these can be called capital N. Next step, go ahead and remove everything from the truss. We have hinge here. We have roller. And I removed everything. It is A, B, C, E, E, F. Where I will put my unit load and how. We are looking for vertical deflection at A. Go ahead at point A, which is here, and put vertical force, unit load 1 Newton or pound, 1 pound. I don't care. It's 1 unit load. Go ahead and solve your truss one more time to figure out what is the value of a small n. Go ahead and submit, construct a table. Put your members, lengths, capital N, small n, and n time L, and figure out the summation. Your final deflection at point A, which is vertical, equals this value, divide AE. So the key in this problem or in this method, how to solve truss.